Hi everyone, this is Charlotte from the Bursary Foundation. I'm back by myself today with a video about a maths topic that you'll often find in your exams, so that is volume and capacity. So you should have heard the word volume before as they start introducing that in Key Stage 2. Capacity you might not have heard, but it's actually a really similar thing. When we talk about volume, what we mean is the amount of space that's contained within a 3D shape. So if, for instance, you get a delivery that has a 3D box, we'd be talking about the volume of the box is the amount of space inside that box, the amount it takes up. So an example could be this cube over here. So we can see that this is a 3D shape, and the volume would be worked out by counting up all of the centimetres squared and cubed piled on top of each other. So you're imagining that if you've got a bunch of tiny cubes and you put all of them next to each other, how many of those cubes it would make to make your 3D shape. Okay. For capacity, we're actually talking about something really similar. We just mean how much liquid something can hold. So for instance, if you have a mug, the capacity of this mug would be how much tea or squash or whatever I can fit within this mug. They are technically two slightly different things in that one measures overall space and one measures liquid. However, in an exam, these words are often used pretty interchangeably. So if you see capacity, don't worry too much. We're just thinking about the volume of liquid that this shape can hold. So the way we work out the volume or capacity of a shape is, assuming it's a 3D shape like a cube or something that involves rectangles, is we do the height multiplied by the width multiplied by the depth. The depth is the bit that makes it 3D. It's how far back the shape goes. Okay, so it's basically like working out area, except you add an additional multiplication onto the end of it. So for instance, if I did the height or length multiplied by the width of this square, I'd get the area of the square, which would be 100 centimetres squared. Multiplying it then by the depth, which in this case is also 10 centimetres, would get me the number of cubes that would fit into this larger cube. Okay, we'd always measure something like this in centimetres cubed or millimetres cubed or something like that. The main thing with that is just pay attention to whether a particular measurement is given to you within the question. We could also have compound shapes a bit like this one, where we'd have to work out each segment of the 3D shape by itself. So for instance, with the bottom row, if this was just a compound shape with area, I'd work out the area of this rectangle, then add the area of the middle shape, then add the area of the top shape. Because it's depth, I'm going to work out the volume of each row and then add it all together. So for instance, the 3 rows for the width are multiplied by the 1 row for the height and the 2 squares going back for the depth, which gets me 6 centimetres. Same thing for the middle, which gets me 4 centimetres. And then the top would get me 2 centimetres, all of those cubed. Then I just add up all of those cubed centimetres, so 6 plus 4 plus 2 gives me 12 centimetres cubed. If you need to practice this, a really easy thing to do would be to draw yourself a bunch of random 3D shapes that use straight lines. Give the lines a bunch of random measurements and just have a go at working out the volume for that kind of shape. So here's an example of how we might use this knowledge in a slightly more complex exam question. So in this one, it says the shaded corners are cut out of this flat shape, and then all the bits that's left are folded up to make a box, and it wants the capacity of the box, by which it actually just means the volume. So here I'm thinking, well, this is basically the net of a 3D shape I've been given. So probably one of the quickest and easiest things to do would be to draw what this 3D shape looks like. So let's imagine that this bit here is the front side of my shape. So I'd get something like this. if I added in the measurements, I can see that this bit going across is worth 8 centimetres because it matches up to the measurement at the top here. And I can see that this height here with the two, I have messed that up, I misread something. So the entire width of this box is 8 centimetres. 1, 2, 3, 4, 5, 6, 7, 8. This is actually 4 here, isn't it? We've just got the 4 boxes shaded in. So that would be 4 centimetres. Similarly, checking down the right hand side here, I can see 1, 2, 3, 4, 5, 6 centimetres there. So this bit would actually be worth 2 centimetres for the shaded in box. So that would be this as the area. If I now need to work out the depth, I need to think about this square here that would attach onto it to go backwards. So what it would actually look like if it was folded up is something like this. Very, very rough drawing here, but you get the idea. So this part would attach back here, and this part would attach over here. Now I can see that this section of the net that's been cut out is 2 centimetres long. So if I was measuring out the capacity of this box, I'd be doing 2 times 4 times 2. So I know that 2 times 4 is 8 centimetres squared, and then I'd do the 8 centimetres multiplied by the remaining 2 centimetres, which gets me 16 centimetres cubed. So the correct answer for this one has to be E as a result. What they're trying to get you to do with some of these other answers is the mistake I very nearly made at the beginning, which is doing 8 times 6 times 6 and something like that, or getting you to take the full measurement and not multiply it by the smaller bits. So do what I almost didn't do and really pay attention to detail and check exactly what this diagram is asking you for. Another common one that might come up is where you're asked to think about the amount of liquid in something. So in this case, for instance, I'm told the depth of this box is filled to 70 centimetres, and I'm also told the amount of litres of water. So I'm told the volume, but I'm not told the width or the depth here. Okay, so I know I'd have my W down here. The 70 is the height, which we've already been given, and I've got the D for the depth of the box going backwards. So what I'm thinking of is, well, what's happening in that case when the water level is dropped by 25 centimetres? Well, I'm going to get a new height here. So this height, I know, would turn into 70, subtract 25, which would get me to 45 centimetres. Now, what I'd like you all to do is pause the video for a couple of minutes and have a think about how we could use this information to try and solve how much water is left. All right, so if you've unpaused and had a think about that, what we have to do here is essentially reverse engineer, because I know that width times height times depth gives me the volume, or in other words, the litres of water in the tank, which in this case is 1,050 litres cubed of water. Okay. So I need to say, well, what are these other measurements? This is really similar to a type of question that you may have seen before, where you get something like the area of this rectangle is 50 centimetres squared. If this side is 5 centimetres, what's the width? So in this case, I'd work out the width by doing, well, I know width times height gives me the area. So if I do 50, divided by 5, that's going to give me the width, which would be 10 centimetres. We're doing the same sort of thing here because I know what the height is going to be, but I don't know the width and the depth. So let's reverse engineer a bit to try and work out what the width times the depth would be, because I know that I originally had a height of 70 centimetres. So if I know that the width multiplied by the depth multiplied by 70 is 1050 litres, to work out the width and the depth, I need to do 1050 divided by 70, which would be exactly the same thing as doing 105 divided by 7 to make it a bit quicker and easier for an exam. And that would give me the width multiplied by the depth. So I'm going to quickly do some workings out at the corner here. So I know 105 and 7. I'm going to create a quick bus stop. So 7 into 1 I can't do, so I'm going to do 7 into 10, which is 1, and there's a remainder of 3 in here. So 7's into 35, if I place that 3 correctly, would get me 5. So I know that the width multiplied by the depth is 15. I don't actually need to work out what the width and the depth are separately, because those aren't changing. I can probably have a good guess and say it's likely to be 3 and 5, but it doesn't particularly matter, because the only bit that really matters is this changing 70 centimetres. So I know that if I do the width multiplied by the depth multiplied by the new height of the water, which we've already worked out is 45 centimetres, that's going to get me the new volume of water, or how much volume is left in there. I also know that the width times the depth got me the value of 15. So if I do 15 multiplied by 45, that's going to get me the volume of water in this tank. So again, quick workings out at the side here. I know that if I do 10 times 45, that's going to get me 450 litres. And if I do 5 times 45, I'm going to break that up. So 5 times 5 is 25, and 5 times 40 is 200. Quickly add it all up. Well, I've got a 5 over here, I've got a 7 here, and I've got a 6 here. So the answer would be 675 litres. If I double check this down the bottom, the only correct answer I can have in that case is E. So hopefully all of that made sense to you, and you understand that because only the height is changing in this question, the exact length of the width and depth doesn't matter. It's that knowledge that width times depth gets me the value that I then need to multiply by is the thing they're looking for you to understand here. If this was in a multiple choice Trafford Grammar School exam, I'd be tempted to say, come back to it later and do some other stuff first, because this involves quite a lot of intense workings out. If it was in something more like an independent school entrance exam, where you are going to get marks for your workings, even if you're not sure about everything, what I'd suggest you do is write down some of this knowledge that we know, like width times height times depth equals the volume, because you're going to prove, I'm not quite sure necessarily what I'm doing with this exactly if you don't have time to finish it, but what I do know is this is the knowledge I need to work it out. So writing everything down is going to be the major point in your favour for any question like this. And I really, really recommend that even for a grammar school exam, you have your scrap paper at the side for your workings out and you write everything down neatly, because I'm not going to remember all of this information in my head unless it's on the page in front of me. So hopefully that was really helpful and you've enjoyed that. Have a go at some more volume and capacity questions in your own time. Use things like your Bond Online resources and let us know how you get on with that. I hope you enjoyed this lesson and I'll speak to you again soon.